how we can identify any of the waveform, whether they come under any of the wave symmetry or not. So we have studied about four wave symmetries in previous class. Those four wave symmetries are even symmetry. Even symmetry is also known as mirror symmetry. Odd symmetry is also known as rotation symmetry. And then we have half wave symmetry. Then we have the quarter wave symmetry. And if the waveforms are coming under any of these categories, then they will follow the rules of that, because there are proved results of all the four wave symmetries. Okay? And we have seen all those results. Now coming to the next topic. Next topic is our exponential form of Fourier series. Now we have already studied about the trigonometric form of Fourier series, and we have studied about the cosine form of Fourier series. Now the next that we'll be studying will be the exponential Fourier series. Now the exponential Fourier series, they are a little different, because in this we are introducing the term exponent. ठीक है, तो exponential Fourier series है तो वो definitely it will be in the terms of exponents. Clear? So the exponent plays an important role here. Now as we know, according to using Euler's identity. Now what is a Euler's identity? Does anyone remembers what are the Euler's identity? I guess everyone has studied about it. Euler's identity क्या होती है? You know, right? What are Euler's identity? It is nothing but, according to the Euler's identity, we can write cos of n omega naught t plus theta n as this one can be written as e to the power Jn omega naught t plus theta n plus e to the power minus Jn omega naught t plus theta n by 2. This is nothing but our Euler's identity. Now this will have to make use of this particular identity in our expression. Now the cosine representation of Fourier series. How do we represent? In cosine form, xt is written as a naught plus summation n1 to infinity an cos of n omega naught t plus theta n. Now this one is the cosine representation of the Fourier series. Now cosine representation, we have a constant a naught, and here it is n1 to infinity. Then we have a coefficient an, capital An, then cos of n omega naught t plus theta that we have already derived. Here now we'll introduce the Euler's identity here. Okay, what is the Euler's identity? As we have seen, it is e to the power taking cos n omega naught t plus theta, and cos of theta, cos of anything, like if I am taking cos of theta, then in that case Euler's identity will be e to the power j theta plus e to the power minus j theta by 2. So here also it becomes the same, that is e to the power, sorry, the j will be taken outside of the bracket. Here also j will be taken outside the bracket. Okay, so this becomes e to the power j bracket n omega naught t plus theta n plus e to the power minus j e to the power n omega naught t plus theta n by 2. So making use of this identity here, this becomes x of t equals to a naught written as it is plus summation n1 to infinity an, and this entire expression becomes e to the power j n omega naught t plus theta n plus e to the power minus j n omega naught t plus theta n whole by 2. So we have just replaced cos of n omega naught t plus theta n by this expression. We can now this expression is very much clear. Now further we can even elaborate it. We can elaborate this particular term. This term becomes e to the power j n omega naught t into e to the power j theta n. And this term becomes e to the power minus j n omega naught t into e to the power minus j theta n. Now this can be, we can even write it separately. X of t can be written as a naught plus. Now I am taking the different terms, that is n 1 to infinity. an will be definitely in common to both the terms. Here also an will be there, here also an will be there. This becomes an into e to the power j theta n. E to the power j theta n will also be there. This I am taking in bracket, then I am having e to the power j n omega naught t. Okay? So this is the first term. This will be, the entire will be an by 2. Since I am having 2 also in the denominator, so it will be taken as an by 2 e to the power j theta n into e to the power j n omega naught t. So this is the first term. Similarly, I will be having the second term. Summation n 1 to infinity. Here also n will get multiplied here. N by 2, and then I am having e to the power j, this is minus theta n. Okay? Now this is inside one bracket. Then outside it will be e to the power minus j n omega naught t. Okay? E to the power minus j n omega naught t. So these are the terms, the different terms that we will be getting. I've just bifurcated it. I've just taken it separately. I've taken the summation to this part. I've taken the summation to this part individually. Now what would be the next step? Let n equals to minus k. Let n. Here also I am having the terms of n. Here also I am having the terms of n. Now I am making n equals to minus k in the second summation only. Okay, so I am taking n equals to minus k for second summation only. How it will be now? Now I can write my xt as, if I am taking in second summation only, for second summation, just remember students, this will be remain as it is plus summation n 1 to infinity. The first term will be as it is, n by 2 e to the power j theta n into e to the power j n omega naught t. This will remain as it is. Now coming to the second expression, this one, okay? This can be written as plus summation a n by 2. Now here n 1 to infinity will become k minus 1 to minus infinity. Replaced by minus k. So k will be from minus 1 to minus infinity. Okay? So this becomes k minus 1 to infinity. This becomes ak by 2. A of minus n or ak, that doesn't make any difference. So we are writing it as ak by 2. This term will become, as I have already taken, j माइनस थीटा n. ठीक है, ये आपका हो जाएगा a to the power minus theta n. This will be ak by 2 e to the power j theta k. ठीक है, this will become j theta k, and then it will be having e to the power j k omega naught t. ठीक है, so that is how I've taken. So here it is minus theta n is again replaced by theta k. A of minus n is replaced by ak, and minus theta n is replaced by theta k. So these are the replacements, the substitution that we have made in second summation only. only in second summation. Now we can even replace it by another variable, कोई और variable में we can integrate. Okay, can be written in terms of n also. हम उसको easily n के terms में लिख सकते हैं. Now we can write it as x of t is equals to a naught plus summation n1 to infinity a n by 2 e to the power j theta n into e to the power j n omega naught t. This is the first summation. Now I can even write it as plus summation. I'm just replacing n, k by n. Okay? This becomes n minus 1 to minus infinity a n by 2, k को n से replace किया e to the power j theta n. Now this becomes e to the power j n omega naught t. Now what is it actually? We can see that here I am having all the terms. The summation is covering all the terms for all the negative values of n, that is from minus 1 to minus infinity. And here it is covering for all the values of n, that is from 1 to infinity. And this is a naught, that we are just saying that this is the value when n is 0. So actually we are covering all the values of n, that is minus infinity to minus 1, then n equals to 0, and then from 1 to infinity. So these are all the values of n. Finally, we can write our exponential form of Fourier series as, that is x of t can be replaced by summation n minus infinity to plus infinity. Now taking another coefficient cn into e to the power j n omega naught t. Now what is cn? I will just let you know. Okay? Now this expression, this particular expression is the exponential form of Fourier series. This is the exponential form of Fourier series, and this equation is also known as the synthesis equation. Okay? This equation is also known as synthesis equation, and this is the exponential form of Fourier series. Now let us see what is Cn here. Now what I am doing here, I have taken this a naught. A naught is the value for n equals to 0, and this are the n by 2 will be having the values for both, that is for positive values of n also, for negative values of n also. Now let us just take c naught is equals to a naught, that is for n equals to 0. N equals to 0 then whatever I am having a naught, that will be covered. Because Cn will be having all the values of n from minus infinity to plus infinity. Now wherever n is 0, n 0 होगा तो ये क्या हो जाएगा? C naught हो जाएगा. And that C naught for n 0, this term will be completely 1. So that will be just a naught. Clear? So C naught is equals to a naught, and this is equals to 1 by t integration t naught to t naught plus t. And what is it? It is just x of t dt. Now in exponential form of Fourier series, I am taking it as the term c naught, and this particular a naught was there in cosine form, and this is also equal to what? This is also equal to small a naught, because the formula that we have written here is the formula of small a naught, and that small a naught was the parameter of trigonometric form of Fourier series. So all these terms are same. That is small a naught from trigonometric form of Fourier series, capital A naught from cosine, and capital C naught from the exponential. So all these terms are same and they are having the same formula. Okay? Now coming to Cn. Cn is 1 by t integration t naught to t naught plus t x of t into e to the power minus a n omega naught t dt. So this is the formula for Cn that we'll be making use of it for finding out the value of Cn in exponential form. ठीक है, तो this is the formula that is t naught to t naught plus t x of t e to the power minus j and omega naught t dt. Now this we can even derive. हम यहाँ से derive भी कर सकते हैं formula को, but that is again not required. We just need to know what is the formula. Which we can derive by taking the summation in common, taking a n values in common, and Cn will be somewhat related to a n also. Capital A n से relation भी है. Now we'll see how it is related to a n. ठीक है. Now this particular equation is known as the analysis equation. This was the synthesis equation. ये जो equation था, this was completely the synthesis equation. Now the equation that we are getting for the calculation of Cn is the analysis equation. Now this equation is very important because by the value of Cn only will be able to plot the spectrum, the Fourier spectrum. Okay. Now what is the Fourier spectrum? Fourier spectrum is the plot of amplitude versus frequency as well as phase versus frequency. तो जहाँ पर हम amplitude versus frequency plot करते हैं, there will be the value of Cn, that is the magnitude of Cn. Where we'll plot the Cn का phase versus frequency, that at that time will take the phase value of Cn, मतलब उसकी कितनी phase की value है, ठीक है? So that is what will need it for analysis purpose. So that is why it is called as analysis equation, and this one is very important. Cn is very important in case of exponential form of Fourier series. So among all the three that we are making use in Fourier series, that is we are making use of trigonometric form of Fourier series, we are making use of cosine as well as the exponential. Among all the three, the most widely used is the exponential form of Fourier series, where we can easily get the value of Cn. Cn को हम calculate कर सकते हैं. Definitely it will be in terms of theta. मतलब इसमें कुछ ना कुछ phase रहेगा because it has the exponential involved in it. ठीक है, so we'll be getting the phase because exponential involved है, तो ये complex है. We know that it's a complex. It will be having the real value, it will be having the imaginary term, everything. ठीक है, so in that case we can calculate the angle, the phase of the Cn also. So this is the analysis equation. Analysis equation मतलब we can plot both the Cn versus omega, that is the angular frequency, and then Cn versus omega will be the phase plot. This is the amplitude plot and this one is going to be the phase plot. और दोनों का plot मिलाकर बनता है Fourier spectrum. ठीक है, so we need to know what is the Fourier spectrum. Fourier spectrum, Fourier coefficient जो रहते हैं xt के, what are our Fourier coefficient? Fourier coefficient is Cn here. ठीक है, तो value of Cn exists, that is the Fourier coefficient xt have only the discrete spectrum. Now इसमें एक और चीज important है, that just make a note of it. The Fourier coefficient xt, the Fourier coefficient of xt have only a discrete spectrum. Because why it has only a discrete spectrum? Because we have the values only at n. n का जो values रहेगा उस पे वो exist करेगा. Like for n 1, 2, 3, 4, 5 उसी पे भी वो exist करेगा. So that's the only reason. तो जो हमारा Fourier coefficient of xt रहेगा, we have only a discrete spectrum. Whatever it is, whether it's an amplitude or it is a phase, दोनों ही case में it will be a discrete spectrum. It will never be a continuous kind of plot. ठीक है, तो आपका जो spectrum plot होगा, तो whether it is this one, that is amplitude mod of Cn versus omega, or whether it is this one, that is angle of Cn versus omega, both the spectrums will be the discrete spectrum. ठीक है, this is an important point to remember, that is only because Cn exists. This point is very important. Cn exists only for discrete values of n. ठीक है. As it represents the complex spectrum, it has both magnitude and phase spectra. It has both magnitude and phase spectra. मतलब magnitude plot भी रहता है और phase plot भी रहेगा. ठीक है. The magnitude light spectrum is always there. Now this is an important point again. The next point is the magnitude. Line spectra. Now we call it as line spectrum. क्यों हम इसको line spectrum बोलते हैं? Because it's a discrete spectrum. तो line spectrum का मतलब क्या हुआ? It is a discrete in nature क्योंकि वो lines के form में रहते हैं. That is why we call it as line spectrum. There is no other reason for calling it as line spectrum. It is always the magnitude line spectrum is always an even function. Even function मतलब क्या है? Even function, we all know what's an even function, right? Even function मतलब it is the symmetric about the vertical axis. It is symmetric about the vertical axis. In that case, अगर हम उसको even function बोल रहे हैं, तो अगर हम इसको plot करेंगे, now let us take it as 0. That is n equals to 0. ठीक है, symmetric about the y-axis, correct? So here, if I am having at n equals to 0, तो यहाँ पर मेरा जो first रहेगा, that will be having the value of n as 1. तो यहाँ पर omega naught, this will be 2 omega naught. Here it will, if I go further, here it will be 3 omega naught. Similarly, minus omega naught, minus 2 omega naught, and it goes. Now, if I am plotting it like this, the same way will be plotted in this way. ठीक है? So the plot will be the even function. It is symmetric about the vertical axis. What kind of plot it is? It is a magnitude line spectrum. It is always an even function. Just don't forget this thing. Magnitude line spectrum will always be an even function. That is, it will always be the symmetric about the vertical axis. Now the next point is the phase line spectrum. Phase line spectrum is always an odd function. ठीक है? It is always an odd function. That means it will be anti-symmetric about the vertical axis. तो ये प्लॉट अगर आपका फेस का प्लॉट होगा तो फेस के प्लॉट में ये क्या हो जाएगा? नेगेटिव साइड में इट विल बी दिस वे एंड दिस वे. ठीक है? तो ये आपका नेगेटिव हो जाएगा. सो इट इज एंटी सिमेट्रिक अबाउट द वर्टिकल एक्सिस. These 2 points are very important to remember whenever you get a question to plot the Fourier spectrum. Then you should remember this point, that the magnitude spectrum will always be an even function and the phase spectrum will always be a odd function. That is, this will be symmetric about the vertical axis and this is going to be anti-symmetric about the vertical axis. Now these are the 2 important points to remember about the Fourier spectrum. Now we just go into the relationship between the trigonometric form of Fourier series and the cosine and exponential. ठीक है? Then again we'll come back to the Fourier spectrum. Now since we know that A naught is equals to C naught. Trigonometric, this one is trigonometric coefficient and this one is what? This one is the exponential coefficient. ठीक है? Now if we calculate an, then we get, now since I'm just directly writing out the results, we can even derive these results. Okay, so that is not required. मैं उसमें नहीं जा रही हूँ कि derivation कैसा होगा क्या होगा, because that is not required. You should just know how we get the result. ठीक है? So that is same when we are writing the exponential form of Fourier series. Xt is summation n minus infinity to plus infinity c of n e to the power minus j n, sorry, e to the power j n omega naught t is the our exponential form of Fourier series. Now in that case we can even bifurcate it, मतलब उसको फिर से अलग अलग कर सकते हैं. c नॉट को अलग लिखे, फिर माइनस इंफिनिटी टू -1 को अलग लिखे, फिर 1 टू इंफिनिटी को अलग लिखे. ऐसे कर करके हम ये इक्वेशंस, ये हम लोग फॉर्मूलाज निकाल सकते हैं. तो देयर आर स्टेप्स टू गो थ्रू इट एंड दैट इज अगेन एज आई सेड इट्स नॉट रिक्वायर्ड. ठीक है. नाउ n इज c of n plus c of minus n. These are the results. Similarly, p of n, it is j times p of n minus c of minus n. ठीक है. तो ये क्या हो जाएगा, j times c of n minus c of minus n. So that is how we can write the relation between the trigonometric coefficients and the exponential coefficient. A naught is equals to capital C naught, small a is equals to c of n plus c of minus n. P of n is j times c of n minus c of minus n. Now similarly, we can even write it as P naught is a naught. Now from here, Cn, we can find the value of Cn in terms of An and Bn. हम Cn लिख सकते हैं in terms of An and Bn. That will be a of n minus j bn by 2. C of minus n can be written as a of n plus j bn by 2. ठीक है. तो either of these we can write. तो या तो हम, अगर हमें ये दिया हुआ है, if these coefficients are given, मतलब if we are given with c of n and c of minus n, we can find out these coefficients, that is the trigonometric coefficient. And if we are given with these coefficients, that is an and bn values, we can even find out the exponential coefficient. So these are interrelated to one another. Now let's check with the relation between the cosine and exponential Fourier series. ठीक है. A naught is equals to small a naught is equals to c naught. This is the thing we already know. Now an, capital N is what? It is root over an square plus bn square, right? It is root over an square plus bn square. Now what is my an? An is cn plus c of minus n. So I can just replace it and I can write it as this one, cn plus c of minus n the whole square plus bn is what? It is j times, ठीक है, j times cn minus c of minus n the whole square. ठीक है. Now further we can write this after solving this one. इसको जब हम solve करेंगे, we will be getting this as 4 cn and c of minus n. ठीक है. cn and c of minus n. This can be, after solving this one, we'll be getting this as an answer. ठीक है. This will be cn and c of minus n. And we can even write it as an equals to 2 mod cn. An equals to 2 mod Cn. So we have got A naught is equals to C naught and An is to mod of Cn. Mod of Cn मतलब जो भी Cn रहेगा that will be An और Bn के टर्म में what is Cn? It is nothing but An minus JDn by 2. तो ये जो टर्म है इसका हम mod ले लेंगे magnitude that will be our An. Clear? So that is how we will be getting this equation. And finally, these are the results of A naught and An. So we have interrelated, that is, as we have seen, all the three form of Fourier series they are interrelated to one another. ठीक है? Now coming to the Fourier spectrum again. Now we will just compare all the three form of Fourier series and we'll find कि किसमें आपको Fourier spectrum better मिलेगा और which one is better in obtaining the Fourier spectrum. Can anyone say कि कौन सा form is better to obtain the Fourier spectrum? Yes, whether the trigonometric form, cosine form or the exponential form. Which one is better to obtain the Fourier spectrum, students? Yes. Anyone who can just guess कि कौन सा form will be better to obtain the Fourier spectrum? It is exponential. Correct. So it's definitely an exponential form will always be better to obtain the Fourier spectrum. Now we'll see how it is better. As we have seen, the Fourier spectrum of a periodic function xt is a plot. What is a Fourier spectrum? It is a plot of Fourier coefficients versus frequency. Fourier coefficients versus frequency omega. Now this we need to know what actually a Fourier spectrum is. It is a plot of Fourier coefficients. So we हमारे Fourier coefficients रहेंगे versus frequency omega का plot रहेगा. ठीक है? Now it consists of two parts. What are the two parts? One is an amplitude spectrum. Another one is a phase spectrum. Yeah, so we have an amplitude spectrum and then we are having a phase spectrum. So these are the two spectrums. Now, the plot of the amplitude of Fourier coefficient versus frequency omega. ठीक है? This is the amplitude spectra. We call it as amplitude spectra. ठीक है? So the plot of what? The amplitude versus frequency is the amplitude spectra, and the plot of the phase of the Fourier coefficient versus frequency omega is the phase spectrum. ठीक है? So these are the basics about the Fourier spectrum, that we should know what is a Fourier spectrum and what are the plots that it involves. It involves two types of plot. One is an amplitude and another one is a phase. So the plot of the amplitude of the Fourier coefficient versus frequency is the amplitude spectra, and the plot of the phase of the Fourier coefficient versus frequency is the phase spectra. So we are having amplitude spectra and the phase spectra, and they both forms a Fourier spectrum. Okay? Now in this one, the type of representation, it is always in the frequency domain. हमेशा ये frequency domain representation होता है. Two plots together are known as Fourier frequency spectra. तो आपका ये Fourier spectra हो जाता है पूरी तरह से, अगर completely हम उसको पूरी तरह से plot करते हैं. And it is always in the frequency domain, and as we have already discussed कि ये आपका हमेशा discrete spectrum रहेगा for the different values of frequencies and omega naught. For different values of n, that is for 1 omega naught, 2 omega naught, 3 omega naught, or minus n omega naught, minus omega naught, minus 2 omega naught, for this. So these are always the discrete spectrum or line spectrum. हम उसको discrete spectrum बोलते हैं और line spectrum बोलते हैं. Now coming to the comparison of all the three forms of Fourier series. तो first में जब हम trigonometry की बात कर रहे हैं, in trigonometry, what are the plots that we can get in trigonometry form of Fourier series? We are getting the coefficient as small a naught, small a n, and small b n. With this, that is, it contains both sine and cosine term. Definitely, it contains both sine and cosine term with positive and negative amplitude coefficient. दोनों में positive और negative amplitude coefficient रहता है, a and b n रहता है, ठीक है? But with no phase angle. इसमें हमें phase नहीं मिलता है. Here now we are not able to get the phase angle, phase plot नहीं मिलता है. We can just get the amplitude plot. Are we getting my point? With this, with the trigonometric form of Fourier series, we are not able to get the phase plot. We can only plot the amplitude with the values of an and bn. Clear? So with this, no phase plot, no phase angles. Now, if I am going to the cosine form, in cosine form, we are calculating in terms of capital A naught, capital A n also. हम capital A naught भी calculate करते हैं, capital A n भी calculate करते हैं, हम theta n भी calculate करते हैं. We used to calculate theta n also. We'll be getting all the three values in cosine representation. What happens? It contains only positive amplitude coefficient. उसमें सिर्फ आपके positive amplitude coefficient रहते हैं, ठीक है? That is an important point to note. It contains only positive amplitude coefficients. तो इसमें क्या होगा? पॉजिटिव एम्पलीट्यूड कोएफिशिएंट ही मिलता है विद द फेज एंगल थीटा n, जिसमें हमें फेज एंगल थीटा n मिलता है. बट व्हाट हैपेंस, देयरफॉर वी कैन प्लॉट द एम्पलीट्यूड स्पेक्ट्रम, दैट इज an. हम इसमें क्या प्लॉट कर सकते हैं? an versus omega. This one is the amplitude, an is the amplitude in case of cosine, versus omega, as well as phase, and theta n versus omega. दोनों प्लॉट कर सकते हैं, an versus omega and theta n versus omega. But what happens? They exist only for positive frequencies. They exist only for positive frequencies. ठीक है? तो that's the only reason it is called as single-sided spectra. Single-sided spectra that exists only for positive values of frequencies. It exists only for positive values of frequencies. Hence, it is called as single-sided spectrum. मतलब सिर्फ एक ही साइड में will be getting the spectrum. We won't be getting for negative side. हमें negative side में कोई spectrum नहीं मिलेगा. So that is for the cosine form. Now coming to the third form, which is our exponential form. Now will be getting everything, that is will be plotting what the mod of Cn versus omega, angle of Cn versus ओमेगा। ये भी आपका फॉर बोथ साइड ऑफ फ्रीक्वेंसीज के लिए रहता है, ये भी आपका फॉर बोथ साइड ऑफ फ्रीक्वेंसीज के लिए रहता है। तो यहाँ पर वी कैन प्लॉट एवरीथिंग, दिस हियर वी कैन प्लॉट एवरीथिंग फॉर बोथ साइड ऑफ फ्रीक्वेंसीज, दिस आल्सो कैन बी प्लॉटेड फॉर both the things, that is for both side of frequencies, and hence here we will be getting double sided spectra, double sided spectra. So here we have got the clear picture कि हमें कहाँ पर कौन सा plot मिल रहा है। Here we will not get any phase angle will not be missing, we can plot only for magnitude, ठीक है। But here we can plot both, दोनों चीज plot कर सकते हैं, that is an versus omega, ये भी plot हो सकता है and ये भी plot हो सकता है, but it exists only for positive frequencies, it exists only for positive frequencies, and hence we'll be getting only single sided spectra। तो हमें सिर्फ single sided spectra ही मिलेगा। Here in case of exponential we can plot both, that is mod of Cn versus omega, and this is phase of Cn versus omega। तो आपका ये magnitude plot भी हो गया, phase plot भी हो गया। So both the plots can be easily plot here, and also for both side of frequency, for both the values of frequency, that is for positive values of frequency also as well as for negative values of frequency also, and hence this is known as double sided spectrum। And as we all know that the amplitude spectra are symmetric about the vertical axis, and the magnitude phase spectra are antisymmetric about the vertical axis, ठीक है। Done. So that was all about the Fourier spectrum that we have studied today, कि what is actually a Fourier spectrum, होता क्या है। It is a plot of amplitude spectrum and the phase spectrum। Amplitude spectrum is the magnitude of the, that is the amplitude का coefficient versus frequency, it's amplitude spectrum, ठीक है। That is the thing of Fourier coefficient versus frequency is the phase spectrum। Now coming to the comparison of all the three, trigonometric, cosine and exponential, this one is much and far better, it's only because that in this one we can plot the entire spectrum, मतलब पूरा spectrum with the positive values of frequency as well as for the negative values of frequency, दोनों side की frequencies के लिए we can easily plot। So that's the only reason that the exponential form of Fourier series is much better, and we call it as we make use of exponential for analysis purpose। Clear now? So that was all about for today's lecture.